So properties of logarithms. We have 5 specific properties of logarithms that we're going to look at. And if you took Algebra 2 last year, we did not do them all last year. 2 years ago? Yes. Last year, no. So the first one is the equality property of logarithms. And it says if we have log base b of some value on the left side equals log base b of some value on the right side, then as long as the bases are the same, that means that this value on the left side is equal to that value on the right side. The arguments are equal. There's a product property. Remember that product means answer to a multiplication problem. So if we have 2 values multiplied together within our logarithm, we can expand the logarithm by adding the 2 logarithms together. Quotient property. Quotient means answer to a division problem. If we have 2 values in our logarithm that are divided, we can expand the logarithm by subtracting. Log base b of m divided by n is the same thing as log base b of m minus log base b of n. And finally, the power property of logarithms says that if we have log base b of m to the p, we can take this exponent on our logarithm and we can rewrite it out in front of the logarithm, which is what the problem says. I just took the p and we wrote it out in front. The exponent becomes a coefficient. So as we take a look at our first example here, we're going to write a logarithmic expression as a sum or difference of logarithms. What we're going to do is we're going to expand on the front page, and then on the back side we're going to condense. So the first one that we see, it's the natural log of e divided by x. There's a division in this problem. So if we go back in here, which of our properties has division in it? The quotient. And so we can rewrite this problem as the natural log of e minus the natural log of x. Okay. So that's all we have to do on that one. We're just applying the property. But I'm going to skip down to number 3 here before I do number 2. Number 3, once again, is a division problem. And we're going to do the quotient property because we have a division. Natural log of x squared divided by the quantity of x minus 1 cubed. This x is greater than 1 is our domain of the function. So the value has to be greater than 1 for us to be able to work this out at all. But what we're going to do is we're going to expand it. And to expand it, because it is division, we're going to say log, natural log of x squared, minus natural log of x minus 1 cubed. Well, that's not the only property that we can use on this problem. If we flip back, or you look back at the top of your paper, we have exponents in this problem. And it says log base b of m to the p. We can rewrite these exponents as coefficients. So the p, the exponent, will become a number in front of the logarithm. So in other words, we're going to take this 2, and we're going to write it out in front of the logarithm. We're going to take this 3, and we're going to write it out in front of the logarithm. And we end up with 2 times the natural log of x minus 3 times the natural log of x minus 1. We want to write our exponents as factors. That's what our directions say here. Express all powers as factors. So we do want to do that.
Do you have to, Since x squared is on the top, does that have to go first when you're subtracting?
You want it first. The x squared, you want what's on top goes first. So the reason that I did problem number 3 first is because I need to digress a little bit. Problem number 2, and there's some straightforward stuff in problem number 2, and there's probably some not straightforward stuff in problem number 2. On problem number 2, when we read this problem, it would be read as log base a of x multiplied by the square root of x squared plus 1. So multiplication means that we're going to have to use the product property, which I'll flip back to in a minute. I do want to point out again that this x is greater than 0 is the domain of the function. We've already calculated it out for you. We cannot do the problem if x isn't greater than 0. But the product rule, the product property of logarithm says that we can expand this logarithm, log base b of m times n, if two values are multiplied together, by putting an addition sign in between there. So when we start this problem, it's going to be log base a of x plus log base a of the square root of x plus 1. X squared plus 1. But that's not it. That's a good start on the problem. But we need to keep going on this one, because we can do something with the square root. And the square root of x squared plus 1 can be rewritten as x squared plus 1 to the 1/2 power. And again, if you took Algebra 2 last year, we did this back in late October, early November, which is why it looks foreign to you. But the square root means that there's a 2 in this checkmark part of the radical. And what happens is when you convert it here, it becomes the denominator of the fraction. So it's not coming out very well. Let me try again with that.
On next page, you can do it.
Okay.
It's like easier to explain on this one.
If we have the cubed root of x squared plus 1, if we rewrite this, then this would be x squared plus 1 to the 1/3. Or if we had the 4th root of x squared plus 1, this would convert to x squared plus 1 to the 1/4. You kind of get the picture? I'm just writing it. I'm just making these up. Just to kind of refresh your memory. And as we get to the second page, and we'll see something similar to that. So when we go back into our actual problem now, we kind of digress for a couple minutes. The log base a of x is not going to change. There's nothing else that we can do to that first term of our logarithm when we expand this. But we're going to rewrite this log base a of x, the square root of x squared plus 1, as x squared plus 1 to the 1/2 power. And when we write that with an exponent, then that's going to allow us to use the power property on here. And the power property says that we take our exponent and we write it as a coefficient. So we're going to get log base a of x plus 1/2 log base a of x squared plus 1. So we've done 3. Let's move on to 4. And once again, what we see in here is we see the x squared. So again, problem number 4. Before we use our properties or apply our properties to these logarithms, let's rewrite the square root of x squared plus 1, which we just saw in problem number 2, again. So we can rewrite this problem as log base a of x squared plus 1 to the 1/2 power. That's the same value. X squared plus 1 to the 1/2 power means the same thing as the square root of x squared plus 1. And then we're dividing it by x cubed times x plus 1 to the 4th. Hang on. Yeah. And then when we look at our properties, what we have to do, because it's division again, is we are going to subtract. So this is going to be log base a of x squared plus 1 to the 1/2 power minus log base a of x cubed times x plus 1 to the 4th. Because it's the fraction, because we're dividing. Quotient property means that we subtract. Well, we still have a ways to go on this one. We've got this 1/2, and we're going to bring out to the front using our power property of logarithms. So that's going to be 1/2 times log base a of x squared plus 1. But on our other value here, we've got some more work to do. Because this is log base a of x cubed multiplied by x plus 1 to the 4th power. So when we write this here, what we're actually going to have to do is we're going to have to apply the properties to this. And we're subtracting, so we have to be really careful. Because if we break this apart, this is going to be log base a of x cubed. What do we do when we multiply? We're going to add. And then this is going to be log base a of x plus 1 to the 4th. They're multiplied, so we can still apply a property to that. Multiplication means that we're going to put in the addition. Our original problem was division. That's why we have subtraction. So now, we can't do anything over here in the first term. 1/2 log base a of x squared plus 1. What we can do in our second part of our problem here is that we have powers on these. So we're going to use the power property of logarithms again. And what that means is this 3 is going to be written out in front. And not only can we apply that property for our first term, but we can apply that property to our second term. It got jumbled up a little bit, but it's 3 that we're bringing out in front, and our log base a of x, plus bringing our 4, using our power property, bringing our 4 out in front. We've got 4 log base a of x plus 1. So one more step.
That's not it.
Nope. One last step is that we can distribute this negative here and here.
So it's negative.
So it's going to be 1/2 log base a of x squared plus 1 minus 3 times log base a of x minus 4 log base a of x plus 1.
Is that it?
There, that's it. I distributed the negative. Negative to here, and negative to there. So let's write each of the following as a single logarithm. We still want to express all powers as factors. And in fact, the first thing that we look at when we're dealing with these problems is do we have a coefficient?
No? Yes.
We do. We've got a coefficient on this particular problem of a 4. So the first step in this problem is that we're going to rewrite it as log base A of 7 plus log base A of 3 to the 4th. We're going the other direction now. We're putting the exponent back into the problem. But can we figure out what 3 to the 4th is? Yeah, and if you don't know it, I don't have my calculator open right now, but you could type it in your calculator, and you would see that this is 81. I moved the 4, back up to an exponent.
So instead of like last time, we would have started out with 3 to the 4th and had to put the 4 back in front.
Yep. So lastly, we need to look. Are we adding these two logarithms together, or are we subtracting two logarithms? We're adding, and what does adding tell us to do when we condense? We're going to multiply. So we're going to get log base A of 7 times 81. And then when we multiply, we actually can figure out what 7 times 81 is. It's log base A. And I don't really need that parentheses there of that 567.
They were already being added. No, like,
when you're working with these here, when they're added goes back to multiplication. So as we look at the next one here,
oh, this is the one.
the first thing that we look at here is, do we have any values in front of the logarithms? We're going to put the 2/3 on the 8. So this is going to be natural log of 8 to the 2/3 power minus natural log of 3 to the 4th minus 8. And we just did 3 to the 4th, so I'm going to write it as 81 minus 8. But what we can do is we can figure out what the value of 8 to the 2/3 is. And I realize that for some of you, you can just type it into your calculator. In fact, everybody in this room has a calculator that will do that. But I want to show you where it comes from. And it's 8 to the 2/3. What happens is we can rewrite it as 8 underneath the radical. The denominator, whatever's in the bottom of the fraction, goes in the check mark part of the radical. And then the numerator is still the power. So if you wanted to figure out this by hand, and I know most of you don't want to figure it out by hand, but I just want to show you how it works. 8 is 4 times 2, which is 2 times 2 times 2. And what we're looking for is we're looking for 3 of the same value to take out 1. Well, we have 3 2's, so we can take out one of them when we simplify that. So the cubed root of 8 is 2. And then to finish this problem, we square it. And 2 squared is 4. On this particular problem, if it's a number to a fraction exponent, you can figure it out on your calculator. The only thing that I anticipate that could be a problem is, do you know how to do this problem when it doesn't have numbers in it? But I think we'll worry about that when we get to there. So if we simplify this a little bit, it's 3 of the same to take out 1. I took out the 2. But remember, there was a squared outside of it, which is why it's the 4. So if we simplify this, and again, ultimately what we're trying to do is we're trying to get down to one logarithm. So we've got the natural log. 8 to the 2/3 is 4. over here, minus log of 81 minus 8, and 81 minus 8 is 73. 3 to the fourth, by the way, is 81, if you didn't hear me earlier. And then what does minus tell us to do? Do we have to multiply? Do we have to divide? We have to divide. So we can condense this down into division as the natural log of 4 divided by 73. So the steps are, figure out, do you have any values in front of the logarithm? Whether it's a natural logarithm or a common logarithm, put those back in terms of exponents. And then look and see, are you adding the logarithms together or are you subtracting the logarithms? So in this particular problem here on number 3, I'm going to do it in a lot of steps. If you can do it quicker, that's fine with me, but I want to show where everything came from. And when you use the order of operations, we work from left to right. So I'm going to combine, first of all, the first two values, because what I notice when I look at this problem is that there's no number in front of that logarithm. There's no number in front of the second term. There's no number in front of the third term, and there's no number in front of the fourth term. So when we combine here, this is going to be log base A. We're adding the first two terms together, and what does addition tell us to do? We're going to multiply. So this is going to be 9x. X on 9. But we still have log base A of x squared plus 1 minus log base A of 5. And again, you can do this quicker, but I want to show you where things came from. So we did the first two terms. Well, now we're going to do the first two terms again. Log base A of 9x plus log base A of x squared plus 1. What does plus tell us to do when we're working with logarithms? It tells us to multiply. So this is going to be log base A of 9x times x squared plus 1. And I'm going to put that all in parentheses there. Minus log base A of 5. Working left to right. Well, we have one more step to go. We have a minus in the problem now. And what does minus tell us to do when we're working with our properties of logarithms? Well, minus tells us that we need to divide. So we're going to get log base A of 9x times x squared plus 1 divided by 5. And if you want to get technical, it really does need parentheses. Next problem. Log base square root of x minus log of x to the 6th. Once again, we see that square root in this problem, and when we have a square root in that problem, we can rewrite this in a little bit better format here. So let's rewrite this as log of x to the 1/2 power minus log of x to the 6th. Well, once we see this, remember that our goal is going to be to condense, and we have a minus sign in here, which means that we're going to use the quotient property. We get log of x to the 1/2 divided by x to the 6th. And we can simplify that value. We have like bases. And the rule when we simplify something like x to the 1/2 divided by x to the 6th is that we get log of x to the 1/2 minus 6. When we divide values with exponents, we subtract the exponents. And what that gives us here is that gives us x to the -11 halves, and I need my logarithm, in front of that, so let me erase that, try that again. But we end up with log of x to the negative 11 halves. So when we condense this here, we want to express all powers as factors, and now that we've simplified that, our last step is to deal with this negative 11 halves, which we're going to write as a factor. We're going to write negative 11 halves times the logarithm of x. And that's our condensed version. We're writing that logarithm as a single logarithm. One thing to point out here is that this is a common log, and just as a reminder, a common log has a base of 10. Just want to remind you of that fact, because sometimes it's out of sight, so it's out of mind. As we finish here on our last problem, what I see is, I see values in here that can be factored. So it depends on how you like to approach this. I know that we have the property in there with the minus sign in between the two logarithms. But let's go ahead and factor our expressions here before we actually apply our properties. So as we look at this first one, it's going to be log, and then up here in our numerator, when we factor x squared plus 2x minus 3, we have x times x. Factors of 3 are 3 and 1, and it's going to be plus 3 and minus 1. Down here in our denominator, we have the difference between two squares, and it's going to become x minus 2 times x plus 2. And we factor there. Over here, it's minus log factoring the numerator. We have x plus 6 times x plus 1. And we didn't have to factor anything in that denominator. Now, we've got that factored, and we didn't have to factor at that point. We could have factored at a different point in the problem. But now what we can deal with is, we can deal with the fact that we have a minus sign in between those two common logs. Well, minus means that we're going to apply the quotient property. So this is going to be log of, I'm going to write in big parentheses here, log of x plus 3, x minus 1, x minus 2, x plus 2, divided by x plus 6, x plus 1, and x plus 2. So they're combining it all. Well, it looks a little bit confusing at that point. So I want to just deal with what's inside this black parentheses for a minute and write it in a little bit different form. If we write it as x plus 3 times x minus 1 divided by x minus 2 times x plus 2 divided by x plus 6 times x minus 1 divided by x plus 2. Remember, when dividing, don't ask why, flip the second one and multiply. So we're going to leave the first fraction alone. We have the x plus 3 times the x minus 1, and then we still have our x minus 2 times x plus 2 times, we're going to flip the second one, x plus 2 divided by x plus 6 times x minus 1. And then what we can look at is, do we have anything exactly the same in the top and in the bottom? Well, we have an x plus 2, and we have an x minus 1. So when we finish this problem, originally, here we had log. I ignored it for a couple minutes. We had our common log. But now what we still have left in our problem is we have the x plus 3, and down here in our denominator we have our x minus 2 times x plus 6. We're taking the logarithm of that entire rational function.